All right, let's continue on with chapter 4. Now, we left off last time with Newton's first law. Continuing on with Newton's first law are included the definitions of inertia and mass. And I have a video, well, actually, I'll show you that in just a moment. But anyway, the inertia is the tendency of an object to continue in its original state of motion. And this is sort of a restating of Newton's first law. And when we talk about an object's mass, a mass is simply just a measure of that inertia. So when I say that an object has so many kilograms of mass, that's a measure of its inertia. And an object with a greater mass has a greater inertia. I have a video that talks about this. This is from the Veritasium series. It's just for your own interest and describes this a bit more in greater detail. You can watch the video here. All right, so let's continue on with Newton's second law. Newton's second law says that the acceleration of an object is directly proportional to the net force and inversely proportional to the mass. So what that is in equation form would look like this. I would have that the acceleration is directly proportional to the force, and the acceleration is inversely proportional to the mass. So then in equation form, Newton's second law, as you've seen it probably, would be F equals ma. Now, this is actually going to be the net force, or the sum of all the forces. We've talked about that. Or you could also write it taking these two relationships as A equals F, the sum of all the forces, over M. We'll write it in this way. I get my pen back here. There we go. That F equals ma. Now, more specifically, Newton's second law can extend to 3 dimensions. So, for example, I can have the force in the x direction, or rather the sum of the forces in the x direction, is going to equal to the mass times the acceleration in the x direction. And the sum of the forces in the y direction will equal the mass times the acceleration in the y direction. You can also apply it to the z direction as well. Let's see, let's work this MCAT problem. Just a moment. Let me grab the book. This is from the Kaplan book. Just sort of one other sample problems. I'll read it to you. It says 1,000 kilogram rocket ship. So I have a rocket ship. That's 1,000 kilograms. Is traveling at 100 meters per second. Let's say it's traveling in this direction, and it has a velocity equal to 100 meters per second, and it's acted on by an average force of 20 kilonewtons. So my average force is 20 kilonewtons. That's 20,000 newtons. In the direction of its motion for 8 seconds. So I have a force, my velocity is in that direction. I have a force applied to this rocket of 20,000 newtons in the motion, direction of its motion, for a time of 8 seconds. 1,000 kilogram rocket ship traveling at 100 meters per second is acted on by an average force of 20 kilonewtons applied in the direction of its motion for 8 seconds. What is the change in the velocity of the rocket? So I want to know what is my change in velocity, and that is I want to know what is the final velocity, because your change in velocity is going to be v final minus v initial, and this is my v initial. So I want to figure out what is my v final. Now, if you go back to your kinematics equations, remember that v is equal to v naught plus at. So I know my V naught and I know my T, but I need to figure out what is my acceleration. So I'm going to work that over here. I have a certain force that's applied to this mass of rocket ship. That force is 20,000 newtons. And my mass is 1,000 kilograms. So 20,000 over 1,000 is 20 meters per second squared. So this rocket ship is accelerating in the positive direction at 20 meters per second squared. So my velocity then would equal 100 meters per second plus my acceleration, 20 meters per second squared, times the time, which is 8 seconds. So that is 100 plus, what's that, 160, we'll call it 260. Meters per second. Keeping proper sig figs, we'd record it as 300 meters per second. The problem is actually asking for what is the change in velocity. So my delta V, the change in velocity is 300 minus 100 meters per second, which is equal to 200 meters per second. All right, that's a basic kinematics Newton's laws problem. You should expect on the next exam to see that type of thing. No. Let's see, have a quick test question here. You can take that a little later, a couple of them actually. All right, let's look at forces. The units of force, sorry, hold on, is this